180 degrees. You can go 1 radius, 2 radiuses, 3 radiuses, and then 0.14 of another. So this becomes our conversion factor. You could also divide by 2 again. 90 degrees is equal to pi halves. But that one has a fraction in it. Okay? Yeah. So this right here becomes our conversion factor. And just like we did with degrees and minutes and seconds, we can write it as 180 degrees over pi radians, or we can write it as pi radians over 180 degrees. So depending on whether we're converting from degrees to radians or radians to degrees, we would want either the degrees to divide out or the radians to divide out. We could use either one of those two conversion factors. They're equivalent to 1. All right, so now you know what a radian is. What are the units of radians? Nothing. Good. Radians are unitless. So when we say rad, we just mean a description to remind us that we're talking about rotation. What are the units of degrees? Degrees, right. Okay, cool. That's a major breakthrough. There it is. There it is in a chart. Okay, there it is in the chart. Okay, so let's go ahead and do example 8. It says convert the following angles from degrees to radians. Leave pi visible in your answer. Okay, I'm going to draw it first. 90 degrees is right here. Okay, 90 degrees. But I want to know how many radians that is. So here's what the conversion will look like. You're going to memorize this soon enough. But again, if you put it over 1, we're going to multiply by a conversion factor. We want to convert it to radians. So to get the degrees to divide out, degrees have to be in the bottom, and that means rad has to be in the top. So what's the conversion factor? Pi over 180 or 180 over pi? Pi over 180. By the way, you could still use 2 pi over 360. That's fine if you want. But pi over 180 is simplified. The factor of 2 is divided out. So it's the simplest conversion factor that doesn't have like a pi halves and 90 like fraction in it. All right, so if you do that, those divide out. And we want to leave pi visible in our answer. So what we really want to do is simplify this. What is 90 1/80ths? What does that simplify to? 1/2, right? So if we multiply across, we get 1 times pi is pi, 1 times 2 is 2. And as we already kind of saw, 90 degrees is equal to pi halves radians. They are the exact same. Pi halves is 90 degrees. 90 degrees is pi halves radians. Okay? So if we're going to have to memorize those, you might want to just memorize it now. All right? So cover your eyes. 90 degrees is pi halves. Good. You already have it memorized. Sweet. What would 45 degrees be? Pi fourths. Good, because that's half of 90. That's half of pi halves. Sweet. All right, 180 degrees. We don't need to do anything here. We know that's pi radians. Okay, pi radians. Go ahead and do this one. 270. Convert it to radians. Again, your conversion factors are either pi over 180 or 180 over pi. You'll know which one to use because you'll need to divide out your units of degrees. Yeah. Yeah, typically we put the number in front of pi. Yeah. So if you can't simplify this in your head, the zeros divide out. So it's really 27 1/80th. Since we want to leave pi visible in our answer, because again, if we don't, it's going to be an ugly decimal that we'll have to round. When we have an angle in radians, we prefer to leave pi visible. So you could do this on your calculator. 270 divided by 180 Hit enter, and then of course you can just hit math, and there's that convert to fraction. Enter, enter. So if you want to do that, that's fine. Okay? And so now it's 3/2 times pi, 3/2 times pi, but the way we prefer to write it is not 3/2 times pi. We prefer to write it as 3 pi halves, right? And again, we don't use 1.5 pi. That's equivalent, but we're going to be working with a lot of fractions involving pi. You're going to memorize what's called the unit circle. You may have heard the legend of the unit circle, okay? Yeah, we're going to memorize that. So 3 pi halves is one of those angles like 90 degrees and 180 degrees that lands on a quadrant. Those are called quadrantal angles, and you're going to have to memorize those. So 0 degrees is 0 radians, 90 degrees is pi halves radians, 180 degrees is pi radians, 270 degrees is now 3 pi radians, 3 pi half radians, sorry, and then 360 would be what? 2 pi radians, yeah. And again, you don't have to write rads after it, right? You don't have to write rads after it. It's just helpful to do that because it keeps you in the context of rotation. 2 pi itself is just a number, okay? All right, let's see if we can stop there for, let's do one more. Let's do the top row, 60 degrees. Go ahead and do one more, 60 degrees, convert it. This is another one that we're going to end up memorizing. 60 degrees lives somewhere up here. If you notice how I write my pies, I don't put the squiggle on the top. I just put a straight line. If you are more artistic, you could do the pie like that. That's fine. Yeah. If you convert it, multiply by pi over 180, 60 1/80th simplifies to 1/3. But another way to do it is say, a full rotation is 360. 60 degrees is a sixth of that, right? So what's a sixth of 360? A third. So it's pi thirds. So 60 degrees is pi thirds radians. Pi thirds radians is 60 degrees. They are the exact same angle, and we will stop there.